in which we are covering one product or system in each session. Our first session was held on 4th of August by Mr. Dheeraj Kumar on TechCell GeoCell, where have covered GeoCell's wide applications in infrastructure projects. The second session was held on 25th of August by Mr. Sailesh Garg on Tech Geomatrices and its various applications. If you have missed any of the sessions, please you can visit the TechFab India's YouTube channel. Today's topic is on an overview of reinforced soil system by Mr. Humit Singh Pal. Mr. Humit Singh Pal is Deputy Manager at TechFab India. He has completed his Bachelor's in Civil Engineering from Indian Institute of Gandhinagar. He is working on projects involving the use of geosynthetics in areas such as reinforced soil walls, ground improvements, and slope stability. So now we will start with today's webinar. And if you have any queries related to the webinar, and you can contact us via telephone or email after the webinar. Thank you. Over to you.
Good afternoon, everyone. Thank you, Khushbu, for the introduction. I welcome you all in today's webinar on an overview of reinforced soil retaining system. So before starting the presentation, let me give you a quick overview of TechFab India. TechFab India was founded in the year 2003 with the objective of providing world-class geosynthetic products and services to enable owners, consultants, and contractors to design and implement reliable, economic, and easy-to-construct solutions for a wide range of geotechnical, hydraulics, transportation, environmental related problems. From a modest beginning with setting up of a manufacturing facility for a woven geotextile in Silvassa, we have rapidly grown to become India's largest manufacturer of geosynthetics in terms of wide range and high quality geosynthetic products. Today, we manufacture a wide range of geosynthetic and geohazard mitigation products at our 6 manufacturing facilities located in Silvassa, Daman, and Haridwar. So our wide range of geosynthetic products are used for different functions in various sectors, such as water resources, hydraulics, transportations, that is highways, roadways, as well as airports, real estate projects, mining industries, and for port and marine works. Here you can see a wide variety of our geosynthetic products. So the first one is woven geotextile. So woven geotextile are available in different strengths as well as in different GSMs. So the major functions of woven geotextile are reinforcement, separation, stabilization, filtration. Non-woven geotextile. So these are also available in different range and different GSMs. So the major function of non-woven geotextile is separation and filtration function. So this knitted polyester geogrid, uniaxial as well as biaxial. And this is polymeric strips or TECHSTRAP. So these two are used as soil reinforcement in reinforced soil walls and other retaining structures. This is polypropylene extruded geogrid, which is used in pavements. This is polyester geocomposites, which is used for subgrid stabilization. These are prefabricated vertical trains, or we call it PVDs. This is a combination of core and non-woven geotextile. This is used for rapid consolidation of soft soils. These are geocells, or we call it TechCell geocell. So these are used for slope protection works and load-bearing applications. We also use TechCell geocells as a ground improvement below our RS walls, where the foundation soil is not competent enough to take the bearing pressure of reinforced soil walls. Then there is drainage composite. So these are so this is a geocomposite product with geonet at the center and geotextile glued on both sides. This is used for drainage applications. Then there is geotextile tubes, geotextile bags, and geocomposite matrices. These are used for hydraulic applications. This is metal gabions. Metal gabions are used for gravity walls as well as a gabion facing with reinforced soil walls. So all these products have Green Pro certification, which guarantees that these are environmental friendly throughout their life cycle. Having successfully met the challenges of ensuring adequate supply of world-class indigenously manufactured geosynthetic products for the growing needs of rapidly expanding infrastructure sector, we expanded our business to serve the needs of geohazard mitigations. We have established a state-of-the-art facility for SDS, that is soil training anchors, high tensile rope net system, and TechSlope mesh flexible slope stabilization system. So our manufacturing facilities are located in Silvassa and Daman, and the recently developed set up plant. We recently set up a plant in Haridwar. So here is a list of all our manufacturing facilities and the products which are manufactured at those units. At Daman, we manufacture non-woven geotextile, prefabricated vertical drains, drainage composite, PP biaxial geogrids, and stable fibers. At Rakoli unit, we manufacture both types of geogrids, that is polyester uniaxial and biaxial geogrids. Tech Glass AIC, TGC, that is reinforced non-woven composite geotextiles. At Athal, we manufacture gabion products, that is metal gabion boxes, which are available in different size, metal gabion mattresses, and wire nets. At Khadoli, we manufacture multi-filament woven geotextiles. At Karajgam, we manufacture TECHSTRAP polymeric strips, textiles, geomatrices, non-woven geotextile containers, and other products. At Haridwar, we manufacture high tensile rope net system and flexible slope supply system, and all other accessories which are required for soil kneading walls. So in 2005, we have set up an in-house laboratory at Silvassa. Our in-house facilities are NABL and GuiLab accredited, and our products which we manufacture, we test it here. We have ISO quality certifications for all our manufacturing facilities. All our geosynthetic products are CE certified from SKZ. Our geosynthetic products are tested at TRI and other NABL accredited laboratories for deriving various test parameters which are used in the designs. So after an overview, let us come to today's topic. So we all know that soil has very high compressive strength, but very limited tensile and shear strength. It can withstand only on its own up to a certain angle. That angle is known as angle of repose. For other steeper slopes, for which we need, for which soil needs some kind of support. So that kind of support is provided by retaining structure. So retaining structures are designed to sustain material pressure of soil or any other kind of material. So there are many kinds of retaining walls. This can be of different types, such as gravity retaining wall, pile, sheet pile walls, cantilever walls, anchored wall, and reinforced soil walls. So gravity retaining walls depends on their mass to resist the horizontal soil pressures. Sheet pile walls are used in soft soils and tight spaces where there is very limited space. They are driven into the ground and are composed of materials such as steel, aluminium. Cantilever walls, these are inverted T-shaped walls made from an internal stem. They transfer the horizontal pressure from behind the wall vertically on the beneath ground. Then there is anchored wall. Anchored walls are those in which anchors are driven into the existing soils or rocks, and concrete is injected by pressure to form a pressure bulb into the soil. And then there is a reinforced soil wall, which we will discuss today. So gravity walls, if we see, gravity walls are easy to construct, but they are suitable up to certain height, that is 2 to 3 meters. Reinforced concrete wall, they can be constructed for moderate heights, that is 6 to 10 meters. Beyond that height, the size of the member increases rapidly. Both this type of uh, retaining walls, that is gravity walls and reinforced concrete wall, they are rigid structures and they have their own certain limitations. As these walls resist the horizontal pressure through their weight, the vertical pressure exerted on the foundation soil is very high. So in certain cases, when such kind of walls are rested on soft soils, the foundation soil is not capable enough to take the applied pressures. So then there is a need of expensive pile foundations to transfer the load to deep strata where soil is strong enough to carry those loads. So another limitations of these kind of retaining structure is that during seismic activity, when these structures are subjected to deformation forces, they, they produce large inertia forces, which tend to destabilize them. It is experienced in the past that many gravity and reinforced concrete walls fail during earthquake events, and reinforced soil walls, owing to their flexibility, does not get much affected. So these retaining this traditional retaining structures, that is reinforced concrete and gravity wall, lacks ductility, and therefore it is shown that there are failures in the past. Overall, the earth retaining structures are classified into two: externally stabilized system and internally stabilized system. Externally stabilized means we are stabilizing the earth or soil by providing an external member which is not interacting with the soil material but supports the soil. It could be a gravity wall, RCC cantilever wall, counterfort wall, or Gabion gravity wall. These walls resist the horizontal pressure through some kind of external arrangement. For example, in gravity wall, it is the mass. In cantilever wall, it is the T-shaped stem. And similarly, in other walls, there is some kind of arrangements. In internally stabilized system, some elements are provided at successive layers within the soil which interact with the soil. The examples are reinforced soil walls, anchored earth, soil nail walls. So the definition of reinforced soil structure. So these are composite structures wherein some select kind of fill is internally stabilized by inclusion of some discrete layer of reinforcement, which are placed horizontally between successive layers of soil filled during construction. So this is a picture of a reinforced soil wall with segmental panels supporting an approach. This is a reinforced soil slope. So how do we categorize reinforced soil walls and reinforced soil slope? So when the face inclination is greater than 70 degree from the horizontal, we call it reinforced soil walls. And if the face inclination is less than 70 degree, we call it slopes. So this 70-degree angle is like is decided based on the practice, and in the guidelines it is like based on various practice we came it is 70 degrees decided. So the advantages of reinforced soil walls. So in India, reinforced soil walls are in use for more than 25 years and increasingly been adopted in various national highways and state highway projects. If we compare the other rigid type retaining walls, reinforced soil walls are cost-effective alternatives. These are very flexible structures, therefore they can accommodate appreciable amount of settlements. Unlike the case of rigid structures in which they do not accommodate any kind of differential settlement. Embedment is the required embedment is very less, therefore there is very minimum cost of foundation. Wide range of facings are available in reinforced soil walls as per the site and aesthetic requirements. These walls are easy and fast to construct. These are very flexible structure, can undergo large deformations during earthquake events without any collapse. So applications of reinforced soil walls. So reinforced soil walls are used as approaches uh, in various national highways as well as state highway projects, to approaches to bridges, flyovers, underpasses, ROBs, etc. These are also used in as shore walls in hilly terrains. These are also used for landscape purposes in residential and industrial projects. So here you can see a picture of reinforced soil wall in one of our projects. So this wall is surrounding one major important building. Other applications are riverbank protections, waterfront developments, and also in soil waste landfills. So these are the components of reinforced soil wall. The major components of reinforced soil wall are reinforced fill, reinforcement, and facings. Other than this, there is a drainage media. There is connection system between reinforcement and the facing. There is a leveling pad. There is PCC leveling pad on which the facing is erected. If the reinforced soil wall is supporting highway, there is a crash barrier or friction slab arrangement. The whole reinforced soil blocks rested on foundation soils. And there are other kinds of fixtures and accessories which are also a component of reinforced soil walls. So let us discuss now one by one different reinforced soil wall components. The first one is fill material. So if we see this figure, there is four kinds of soil are present in this figure. So first one is the reinforced fill, second one is the retained fill, third one is embankment fill, and fourth one is the foundation soil. So basically soil is the major component of reinforced soil wall. Reinforced fill with the soil reinforcement layers, this whole we call it as a reinforced soil block. The retained fill exerts pressure on the reinforced soil block, which is also known as backfill. So if the out-to-out carriageway is very high, some other kind of fill is used here. Its specification is mentioned in MRTH. So the pressure exerted on the reinforced fill depends uh, on the properties of the retained fill. So this triangular wedge, which is at an angle of 45 plus pi by 2 from the horizontal, exert horizontal pressure on the reinforced soil block. So the properties of retained fill also governs the design of reinforced soil wall. Then there is foundation soil, on which the whole reinforced soil system rests. So what are the requirements of fill material? As fill material is a major component of reinforced soil wall, let us look at the requirements. The first one is the reinforced fill material shall be free draining with majority of shear strength component derived from internal friction angle. The material shall be granular because uh, the material shall have good interaction with the soil reinforcement. The fine content shall be less than 15%. The maximum particle size shall be less than 75 mm. And plasticity index shall be less than equal to 6. That is, overall the material shall be free draining, non-cohesive, and having good internal friction angle. So in general, the friction angle shall be greater than 30 degrees. So this is the desirable gradation of reinforced soil fill. This is as per IRC SD 102, which is a guideline for reinforced soil wall designs. Other than normal fill, sometimes it is asked, can fly ash be also used as a reinforced and retaining fill? So yes, fly ash conforming to IRC SP 58 can be used as a reinforced as well as retained fill. Other than the properties discussed above, fill material shall be free from organic or other deleterious materials and shall not react adversely, that is chemically, electrically, or biologically, with the reinforcement material or the facing material. As the reinforcing material can be of steel also, the soil must have certain electrochemical characteristics, that is pH, resistivity, and chemical contents. These properties or these characteristics values shall be within the specified limits which are given in the code. Also, the reinforced fill shall be placed over the reinforcement shall be compacted for a thickness of 200 mm. This well compaction ensures that the soil achieves adequate shear strength. So after looking at the reinforced fill properties, let us look at the types of facing and the functions of facing. So what is the major function of facing? So facing is basically used as a formwork to contain the fill during the compaction, because there is some kind of confinement is required when soil reinforcement and fill material is placed over. This stabilizes the fill against traveling and erosion and also protects the soil reinforcement. So uh, based on the requirement of the site and uh, as well as the site requirement, ease of construction and ability to accommodate the profile. For example, the terrain where reinforced soil wall is constructed, we have a variety of facing options. So let us look at the different types of facing options. So available for facing options are of different shapes of steel reinforced panels, such as T panels, square panels, segmental panels, modular concrete blocks, metal gabions, and weld wire mesh facings, and wraparound facings. These facings are connected to soil reinforcement with certain kind of connection systems. This is a wraparound facing wall in which the geotextile or geogrids are generally used as soil reinforcement. Certain measures shall be taken to protect the front side of the wraparound walls, as there are chances of vandalism in such kind of walls. This is a modular block wall in which in general geogrids are used. There is segmental panel in which either geogrids, geostraps, and other kind of steel reinforcement can also be used. There is metal gabion. There is a metal gabion with facing with RS wall with metal gabion facing in which geogrid is used. So let us look at few examples of facings. So this is reinforced concrete segmental panel. This one is a plus panel and this one is a T panel. So the requirement of grade of concrete for these type of reinforced concrete panels is M35. And the soil reinforcement which can be used are geogrids and polymeric strips. Next one is concrete modular blocks. These blocks are are uh, of 200 mm height and 450-meter wide and 300 mm depth. So these are available in different shapes, and geogrids are in general used as soil reinforcement. So here you can see a picture of modular blocks laid, and over that geogrid is placed. In this, the geogrid is 100. Geogrid placed is of 100% coverage, and over it, the second layer of blocks are placed. The other facing is metal gabions. So metal gabions are available in different sizes and shapes. In general, TechFab India has metal gabions of 800 mm to 500 mm height, 1 meter wide, and 2 meter length. So in the geogrids are used as soil reinforcement in this kind of facings. Geogrid is connected to the metal gabion facing unit through a connector rod. Such facings are preferable for waterfront structure. Here you can see a reinforced soil wall with metal gabions at Navi Mumbai International Airport. So this is one of the photograph of the reinforced soil wall post monsoon. The other kind of facing is weld mesh facings. So weld mesh facings are available at unit heights of 500 mm to 800 mm. Geogrids are in general used as soil reinforcement. Some kind of uh, some kind of connection system uh, is also present with which geostraps can also be used as soil reinforcement. Here, geogrid is connected to the facing through a steel rod, similar to the one in which metal gabions are used. So after facing, let us look at the soil reinforcement. So soil reinforcement, basically both polymeric as well as metallic type of soil reinforcement are used. Function of soil reinforcement is to resist the lateral forces from the retained backfill. Metallic reinforcement, these are inextensible reinforcement. So examples are steel strips, wire mesh, etc. Polymeric or geosynthetic reinforcement, these are flexible. In flexible, extensible reinforcement, examples are GeoGrid, polymeric straps, geotextile, etc. Types of GeoGrid. Based on the manufacturing process, GeoGrid are classified as follows. Woven GeoGrids manufactured by weaving together polymer-coated polyester fibers in horizontal and transfer ribs. The crossovers are joined by knitting process, and thereby the geogrid is protected using some kind of coating. Knitted geogrid, they are manufactured using high density polyester yarns. The yarns are knitted into dimensionally stable network of apertures, providing tensile strength capacity in both directions. If it is a uniaxial geogrid, the tensile strength in one direction is high, other direction is nominal. If it is a biaxial geogrid, in both directions, the tensile strength is equal. Then there is another kind of geogrid, bonded geogrid. They are produced by bonding and usually they are at right angles. Then other one are extruded geogrid. They are produced by extruding polymers. They are in general very rigid in nature in comparison to woven geogrids. Let us look at the TechGrid geogrids. So these are manufactured at TechFab India. These are uniaxial knitted polyester geogrids with a protective proprietary coating. The manufacturing process is these are manufactured from high quality materials using state of the art weft insertion warp knitting technology from Karl Menzel of Germany, which are world leaders in this field. So these geogrids are coated. The coating ensures that the geogrids are dimensionally stable and protects it from installation as well as ultraviolet damages. These are the properties of the yarn. The yarn has high tenacity, high modulus, low creep, molecular weight is greater than 25,000, and CGC is less than 30 moles. So these are the requirement of a geogrid to be used as a soil reinforcement in reinforced soil walls. So here is a technical specification of uniaxial TechGrid GeoGrid. So TechFab India has GeoGrids of wide range of tensile strength from 40 kilonewton per meter to 400 kilonewton per meter. These are the reduction factors of GeoGrid. Based on that, we derive the long-term design strength of GeoGrid. So long-term design strength is calculated based on this ultimate tensile strength divided by all the reduction factors. So why long-term design strength is calculated? Because we uh, assume that the geogrid is used for 120 years of design life. So let us look at the advantages of TechGrid geogrid. So these have proven performance in reinforced soil walls and soils as and slopes as soil reinforcement. These are available in wide range of tensile strength. They have excellent durability film, to fill materials that is and also have excellent frictional interaction with the fill material. The other kind of soil reinforcement is polymeric strips. So these are flat web structure comprised closely packed and tensioned parallel bundles of polyester filament tendons, which are encased in linear low density polyethylene sheath and coated with polymeric coating. So these are also used as a soil reinforcement in reinforced soil walls. We call it TechStrap, and they are available in different grades based on the characteristic tensile strength. So we have TechStrap from tensile strength 30 kilonewton to 100 kilonewton. So these are the reduction factors based on which the long-term design strength is derived. So let us look at the advantages of TechStrap polymeric strips. They have very low creep value, they are very easy to install, high resistance to weathering, readily available for execution of RS ball. As they are available in rolls, they can be transported to the site and easily just unroll it, and they can be connected to the connector, and right, and they have excellent friction interaction with fill material. So after looking at the four types of reinforcement, TechStrap and TechGrid, let us look at what all parameters this shall be tested. So both GeoGrids and polymeric strips are tested for creep, installation, connection strength, tensile strength, durability, molecular weight, and also for interaction parameters using pull-out and direct sliding test. For pre-installation damage, these products are tested at TRI USA. For connection strength, tensile strength, and other parameters, these are tested at NABL accredited laboratories and IITs, where testing facilities are available. So after looking at the fill material, facing elements, and reinforcement, let us look at the drainage media. So drainage is also an important uh, consideration in reinforced soil walls. So in general, drainage bay of 600 wide is used at the back of facing. Alternatively, geocomposite drain can also be used. So in general, what kind of drainage media can be used uh, is depends on the availability of drainage aggregate near the site and type of the reinforcement material, as well as the gradation of the fill material. For example, geocomposite drain. If you want to use geocomposite drain, uh, you need to look at the apparent opening size of the geotextile so that the fill material does not clog the geonet drainage medium. So uh, these geocomposite drains are in generally used uh, where there is scarcity of natural aggregate material. So with this, we cover all the major components of reinforced soil walls. These are the different reinforced soil design codes. This is FSWA, this is PS 8006, this is German code, and this is French code. So based on these guidelines, as well as IRC SP 102, reinforced soil walls are designed. So this is the reinforced soil design steps. So basically this presentation was about an overview of reinforced soil walls. So we will cover this in detail in the upcoming webinars. So in general input data, we require wall height, soil surcharges, properties of reinforced and reinforced fill, retained fill, loads applied to the structure, type of reinforcement, type of facing element. So preliminary based on these properties and the loads, uh, we decide the preliminary size as well as the geometry of the requirement of the wall. So after doing the preliminary sizing based on this analysis, that is external stability, we check for sliding, overturning, and bearing capacity. And internal stability, we check for internal sliding, rupture of reinforcement, and pull out of reinforcement. Other than external and internal stability, facing connection is also checked. So here are few of the finished RS wall photographs. So these are reinforced soil walls, which are at the approach of uh, some kind of VUPs. So there are some other walls outside India. So these are walls constructed with TechGrid GeoGrids in Korea. So overall, TechFab India has executed around 45 lakhs of facing area in NFI projects. State PSP, we have covered around 6 lakhs of facing area. Others, we have covered around 4 lakhs, and overseas project, we have covered around 1 lakh 50,000 square meters of facing area. So with this, we conclude today's presentation. Thank you everyone. For any queries, kindly contact at the given mail ID. So in today's presentation, we gave you all an overview of reinforced soil retaining structure. We will be conducting a series of webinars covering detailed reinforced soil designs and other advanced topics in the upcoming presentations. So with this, we conclude today's event. Thank you.